Hi, I'm Greg Reith, and this video is a presentation of astronomical research carried out by Stephanie Yoon, Madison Skull, Anthony Pyro, and myself. The research question we were interested in addressing is if there is any significant trend or relationship between the axial ratio of spiral galaxies and their color index. Our question is motivated by the effect an axial ratio has on electromagnetic radiation of a spiral galaxy, and in turn, how that is reflected in the color it displays.
Our first figure is a scatter plot of the axial ratio versus the Gmag minus Rmag color index. This graph shows us that there's a negative correlation between the axial ratio and the color index. So as the axial ratio decreases, the color ratio should increase. Our next figure contains the statistics taken from a table of just red spirals. This data tells us that the mean axial ratio for the red spirals is close to 1. This result opposes our scatter plot and our hypothesis that the axial ratio should be closer to 0 for red spirals, not 1. Next, we have statistics for blue spirals. These results also oppose our hypothesis because the statistics show that the mean axial ratio for blue spirals is lower than the axial ratio for red spirals, and we hypothesized that blue galaxies should have an axial ratio closer to 1. Additionally, the blue spirals seem to have a greater standard deviation than red spirals do. Our first visualization is a blue spiral. This spiral in particular is fairly flat, so it appears blue to us. Our second visualization is a red spiral. This galaxy appears to be tilted to a large degree, so it looks red.
Initially, we expected to find a relationship between the axial ratio and the color of the galaxies. Through our research, we found that as the axial ratio decreases, the color ratio increases, meaning that there is a relationship between the two categories. However, when we created statistics of the red spirals and blue spirals, this disproved our hypothesis because of how the axial ratio for blue spirals is lower than the axial ratio for red spirals. Because of these statistics, our assumptions were incorrect, and we came to a conclusion that the axial ratio and the color of the galaxies do not have any correlation. Although we did find some data that proved our hypothesis, there were also data we found that disproved our hypothesis, so we cannot say for sure that there is a relationship between the two categories. After our discoveries from this project, a follow-up question we had was, could the different kinds of light, like Rmag, Gmag, Imag, Umag, have an effect on the axial ratio? This interested us because we thought that we should not use a red versus blue approach, and instead we should use the different kinds of light.
Throughout the duration of this project, our group found two main takeaways. The first is that when setting out to do research in the sciences, the research question you end up answering can be very different from the one that you initially set out to answer. As we began digging into the initial question, we realized that the aspects of the galaxies we chose to analyze had no correlation at all, and so we chose other aspects for our final research question. Another takeaway we found is that science does not progress linearly. Rather, in pursuing a question, you must jump back and forth between the research question, your hypothesis, data gathering, and data analysis. The science never really stops, it just continues to evolve.